Welcome to the Hitachi Surge Protection System Overview video. In this video, you will discover what is a surge, how it can be protected against, and why the Hitachi SPS is the best solution for your surge protection needs. Today's world is run by sensitive microprocess-based equipment that are susceptible to transient surges. A surge is defined as a high amplitude overvoltage with a very short time duration. Surges can be generated from both an external source and an internal source. The most obvious and dramatic external surge source is lightning. A more common external generator of power surges are produced from utility grid interactions. Utility substation switching and capacitor bank switching can put transients directly into the distribution system. Internally generated power surges are more common and account for 70% of all surges experienced by most facilities. Any reactive load that turns on or off, such as motors, AC handlers, and pumps, generate damaging surges. While these internally generated surges are not on the magnitude of a lightning strike, they cause damage over time through degradation of sensitive electronics. The rapid proliferation of complex electronic equipment, which is inherently intolerant to surges, drives the need for robust surge suppression protection. Surge protective devices are the least expensive and the most cost-effective first line of defense against transient problems. Operation of an SPD is relatively simple. The SPD becomes the path of least resistance to transfer the surge energy out of the system to ground before the surge has the opportunity to damage any electrical load. This simulation shows what can happen to a motor when it is subjected to a 60,000 amp transient at 19,000 volts with no surge protection. The coil is similar to the coil of a motor connected to line voltage, and the can placed inside the coil is similar to a rotor. The can is crushed due to the magnetic field generated from the transient current propagating through the coil. Running the same simulation with the Hitachi SPD in the circuit results in no damage to the can. Instead of the surge current going through the coil, the SPD took the full force of the current and sent it to ground. Most SPDs utilize metal oxide varistors, commonly known as MOVs, as their principal surge protection element. MOVs are a variable resistor, meaning they change resistance depending on voltage. When voltage rises, MOVs become the path of least resistance to transfer surge energy out of the system. Under certain power quality events, MOVs can augment problems through catastrophic failure. As current flow continues through the failed MOV, heat builds up causing the MOV to rupture and release gas. Older style SPDs containing suppression circuits comprised of multiple paralleled MOVs are prone to magnification of this type of failure. To ensure safe operation of SPDs, MOVs need overcurrent protection and thermal protection that must be properly coordinated to prevent massive SPD failure. Hitachi SPDs use the latest in surge protection technology to ensure the safe operation of our SPDs. All Hitachi SPDs incorporate state-of-the-art thermally protected MOVs, commonly known as TPMOVs. This MOV is a large block, 34 mm square, distribution-grade MOV rated at 50,000 amps. The TPMOV optimizes thermal protection, creating overcurrent protection. Each TPMOV is individually and integrally fused. Because the TPMOV is one homogeneous unit, it eliminates all the tolerances between the MOV, fuse, and thermal cutouts, creating optimized, efficient MOV clearing. The elimination of these tolerances and coordination issues ensures safe SPD operation. Hitachi's line of SPDs are UL 1449 listed to the most stringent performance and safety standards and provide robust surge protection for even the most severe transient environments. Speak to your supplier today and ask for the Hitachi Surge Protection System by Hitachi Critical Facilities Protection to ensure your equipment is protected from surges.